So we need to take a look at what these things are saying and what makes them different than the ones we did yesterday, because they seem like they're almost identical. Okay, so what it says is if corresponding angles are congruent, then the lines are parallel. So how is that different than what we said yesterday? Oops. Any ideas? What did we say? What was yesterday's? Paste that right on here. You might need to draw a little bit on the side, like on the edge, but just so that you can see what's happening. So in both cases, we have two lines and we have a transversal, right? We've got a transversal. Two lines and a transversal. So yesterday we said if what? If what had to be true about these two? They had to be what? Not the lines. The lines had to be parallel. If the lines were parallel, then the corresponding angles would be congruent. Okay? This one's different. This one's backwards from that. This one says if the corresponding angles are congruent. Okay, so here's an angle. Angle 1, and here's angle 2. They're corresponding angles. So it would say if angle 1 is congruent to angle 2, I'm designating that with the individual swoop, then the lines would be parallel. So if angle 1 is congruent to angle 2, then L is parallel to M. Yesterday said if L is parallel to M, then angle 1 is congruent to angle 2. Okay. Now, this is one case where converse means the same as, or it has the same truth value as the original statement. That doesn't always happen, but in this case it does. So if the lines are parallel, then the corresponding angles are congruent. If the corresponding angles are congruent, then the lines are parallel. So our conclusion in this converse statement is that we have parallel lines. Okay. The originals we talked about yesterday, the conclusion was that we had congruent angles. And hopefully by the end it'll make sense why we need both of them. Okay. We have another converse here. So you could just slide that in over the side if there was room. We have the alternate exterior angle converse. So I'll throw that onto this so it'll let me draw. I'll move this down here. So alternate exterior angles. So if we're thinking about this, we still have L and M. I need to think about alternate exterior angles. So that would be one here. Can somebody describe where angle 2 would be if we're thinking alternate exterior angles? Abby?
The 2 would be on the other side of the line, all the way at the bottom.
All the way at the bottom, good. So if angle 1 is congruent to angle 2 in this case, if they're like that, then what would be the conclusion? Then the lines are parallel. So we would be, how would that look in this specific example? What do you think, Rick, what do you think? Angle 1 is congruent to angle 2, then in this specific example. Isaiah, what do you think?
I don't know.
Alana, what do you think? They would be parallel, so L would be parallel to M. The notation is, when you've got the two lines there like this, that means parallel. So angle 1 congruent to angle 2, then L is parallel to M. So converse of alternate exterior angle theorem. So all of the conclusions for these four that are on the front of this page are going to be then the two lines are parallel. Okay, let's get the next one. The next one says here. Okay, take a look at it. Down here, paste it in here. So we could draw ourselves a little picture, just so you're seeing what's happening. We have this, and I've got M, and I have N.
I do not know.
M is, so if you're done, you can string fast.
Yeah.
Make a guess. Anybody guess? Okay, but let me know when you're finished, then you'll be finished, but you gotta let me know, but you can't take a sleep in the middle, and then because as soon as you finish, then you need to join the class for new stuff. Okay, so alternate interior angles are congruent, so here would be some alternate interior angles. So what kind of a statement would we make? What would be our if-then statement that goes with this picture that we just drew? If what, then what? What do you think, Shane? Okay, so it's going to start with angle 1 congruent to angle 2. These are alternate interior angles. Then, no, the lines are parallel. So the last two, so what lines are parallel? M and N are parallel. M is parallel to N. So all of these that we're looking at are ending with parallel lines. All of these four that we're ending with have the end of the statement, then the lines are parallel. So in pictures, if you have the appropriate angles that have that relationship, the conclusion is that you've got parallel lines. Let me pull the next one up. This one. Copy. See, there it is. Okay, here's this one. So we'll make another picture because we've got two lines and we've got a transversal to deal with. Doesn't matter which way the transversal angles. I could have, these are my labels for my line. Consecutive interior angles, I can't mark them congruent this time because consecutive interior on the same side of the transversal. But I could say if, let's see, what does supplementary mean? Milo, let's, oh, go ahead, Angelina.
They both equal 180 degrees.
So they add up to 180. So that means this beginning part would be if the measure of angle 1 plus the measure of angle 2 equals 180. Mm-hmm. So, okay, thank you. Okay, you can either scoot this Sure, for today.
You want me to do this?
Yes, please. Thank you. Okay, so if measure of angle 1 plus measure of angle 2 equals 180, then our conclusion is
That's what I mean.
N and L are parallel, so N is parallel to L. Right, so the conclusion, the thing that you can know with all of these converses, which we talked about what those different angles meant yesterday, the conclusion is that the lines are parallel. Okay, so we have one more to look at on the back page. We looked at all of these original statements. They started with if the lines are parallel, then the angle relationships have these. These are if the angle relationships were these, then our conclusion is that the lines are parallel. So two different things. Momentarily, we need to grab the next thing from here. Okay, let's put that in. Go and pull that up a little so we've got both of them here. More or less, there we go. Okay, if two coplanar lines are perpendicular to the same transversal. Okay, so two coplanar lines are perpendicular to the same transversal. Okay, so I'll start with drawing the transversal. So here's my transversal first. Start with the transversal. If two coplanar lines are perpendicular to the same transversal, what's perpendicular mean? Nico, what's perpendicular mean? No? Okay, thank you, Joshua. They make 90 degrees. So here's one of the lines. His name is Jordan. I'm sorry. Jordan. I've got Joshua. I've got everything. Everybody's all jumbled. I'm sorry. All right, so this is one of our lines. Okay, so there's going to be two of them. And then there's another one that is perpendicular to that same transversal. Here's our transversal. Here's our other line. If two coplanar lines are perpendicular to the same one, so here's another one that's also perpendicular, then our conclusion is that then M is parallel to N. And that should make sense because it's really just the corresponding angle converse in a different form. So our job then is to be able to take that information and use it and apply it to other things.
Could you go down?
Just down,
Yeah.
like, there's nothing underneath
Oh.
of this. There's some things further up. Like up here.
No, I thought that if,
So there's nothing
oh,
else
there's no-
below. Because what I'm doing, because it doesn't let me actually just write on the screen for my pre-made thing, so I have to paste it onto the paint so that it will work. And so there's that. Is this running? I don't think it's running. Okay, so our converses, just to reiterate, okay, the converses all end with the idea of lines parallel. So here, corresponding angles, if the corresponding angles are congruent, if one is congruent to two, then L is parallel to M. Here, alternate exterior, both on the exterior alternating, then the conclusion is that L is parallel to M. Here, alternate interior, I changed up the names just so that you wouldn't think nothing was true. I'm sorry, I was mistaken. Actually, I think it's probably a bad idea for you to be there because I have to stand and I keep
Hang on.
I was definitely in the line of sight. Anyway, so angle 1 congruent to angle 2 because they're alternate interior angles. So if they're congruent, then parallel to M, consecutive interior angle converse. If these two add up to 180, then the lines are parallel. I've got the then part here. Then the lines are parallel. And then finally, if these two are perpendicular to the same transversal, then they have to be parallel as well.
We need mirrors.
They would be, they do, yes, it's gonna be put up on YouTube and I will put it as not public. Don't do that, thank you. Because it would be great to be able to, you know, like, I always remind students also that if somebody's acting up, it's like proof because everything is recorded. So yes, you're being recorded. So I've told you that. All right, so knowing those theorems and applying those two different things, so we're going to take a look at this one. Our instruction on this is to find x so that A and B are parallel. Okay, so we need to find what would be in here to make it so that these two would have to be parallel. I'm going to put this right over here so we can work with it. It's down to a nice clean spot. All right. So if we're working on making sure that these two lines are parallel, first of all, these labeled angles, what's their relationship? What are they called from yesterday and today?
Or the lines A and B are parallel.
So these two are called, what's the name of these two?
Corresponding? No.
Corresponding. They're corresponding angles. So what do we know about the corresponding angles? What do they have to be in order to have parallel lines? Well, congruent. They have to be congruent. Congruent is another way of saying the numbers have to be equal. So what equation could we set up? Yes.
In parentheses, 3x plus 15 parentheses equals 5x minus 13 parentheses.
Oh, this is a bathroom.
No, I was gonna answer.
But
That was a bathroom.
okay, so don't call out for that, but both of you called out. So I can't just say he gets to. So
I
go
think
ahead.
these are both
Yes.
no.
No, not at the same time. Okay, so here's the thing. There's nothing multiplied times the parentheses. So what we can do when we solve this problem is just drop the parentheses. All right, then we need to review your algebra skills again. So in order to do this, what will we do first in the equation? Yes,
Subtract 3x on both sides.
subtract 3x on both sides. Beautiful. Because then we have 15 equals 2x. The x is on just one side now. Minus 13. It makes a nice, easier problem. Abby, what next?
Then you're going to add the 13 to the 15.
Plus 13. So 2x equals 28.
Divided by 2.
Divided by
Side.
2. That gives you 14. So we've got 14. And then we need to find, so it says how much would x have to be, so we can actually be done with that, because our original problem just said, find x so that A and B are parallel. If they ask you to find the angle, you take the 14 and plug it in, and we'll find out what number one. Okay, so it's asking you, what would you have to find so that A and B are parallel? So that's a good question.
That's fine.
Now we need to start looking at proofs again. I don't have anything. If it was for the class, I would have announced exactly what the conversation was, so it's not your business, anybody. Okay, so, no, I don't mean you, I meant because there's people that were asking that were not you, because it was between you and me. All right, so, when we do a proof, okay, in this case, our goal is, if we have angle 1 and angle 2 being supplementary, our goal is to make sure that we're finding out that L is parallel to M. We're going to be using our theorems. Yes, I have the whole thing filled out for you, but what I would like to do is I would like to take it a piece at a time. So I'm going to cover it up. Actually, I'm going to cover up the next one. My reasons. Where is, don't wait, I don't want you to see that yet. There we go. Because I don't want you to just see all of them all at once. That doesn't help you. Here we go. So what we want to do is we want to go through the reasons that go with those statements. Okay. Now, what this is it's a logical path that goes from my given information that ends with what we're trying to prove. Okay.
Oh, I hate like this. When is this gonna stop?
It's going to be several more chapters. So you need to be
I
able
don't understand this like at
to,
all.
right. So
Are you serious?
taking it from step 1 on this, okay? Because we need to be able to find out, there's always a good reason for everything that we're going to show, okay? What a lawyer will do is a lawyer will take a bit of information and add it to other bits of information, and they will put all that together to convince a jury that they have proved that somebody is guilty or they've proved that somebody is innocent. So they're going to go through and they're going to have to use this idea of logic to do this. So the logic that is intertwined in geometry is just the beginning of that with something concrete, okay, so that you can learn some reasoning skills. So that's part of what's in geometry. But it's also good for like architects because they want to be able to build something that they're sure is not going to fall down. So they have to always justify everything that they do so that when a project is built, that it's going to be something that's safe. Okay, a city planner is going to want to plan where the different things are so that there's enough room so that when the cars are turning around that there's not traffic jams in different places. So they have to figure out how all the things react with one another so that we have this logic happening. Now, if you don't see yourself in any of those careers, the other reason you have to do that is because in order to graduate high school in New Jersey, you have to take geometry. So there you have it. Yes.
Yeah, like what is Isaiah doing, bro?
I'm not here. Like we only learn just
Okay. All right. So anyway.
Miss Dowdy, I have a question.
Yes.
Is it MRS or is it MS?
Oh, for me?
Yeah.
Mrs. MRS.
MRS?
Okay.
Yeah.
All right. So here we go. So back to this. You have to have something that's given to you. And so our given information is the picture. Sometimes you don't have to list the picture. Sometimes it's there and sometimes it's not. So if the picture isn't listed, that's fine. But here, notice that I'm starting with the idea that angle 1 and angle 2 are supplementary. You have to start with something, so that's given to you. Okay, so I looked at what I was given, and then I figured something out because of what was given. So how do I know that angle 1 plus angle 2 equals 180 degrees? You have to take into account the picture. You have to also take into account the word. So can somebody just explain in words, even if it's not a formal reason, how do I know that angle 1 plus angle 2 is 180 degrees?
So supplementary, you said that when each bigger equal 180.
Good. So because of this word supplementary, that's what the word supplementary means. So when it's just, that's what that means. Yes.
Can we put given?
No, wait a minute. Sierra had a question with her hand up. Yes, Sierra.
I was about to say, but I understand now.
Okay. So when you just say, well, like she said, well, you said that supplementary means it equals 180. Whenever your thought process is that, that's a definition. Okay, that's just what that means. That's a definition. So 1 plus 2 equals 180. That's just what supplementary means. So it's the definition of supplementary. Okay, so definitions are basically if you're just saying what it means in a different way. Usually it's taking words and making them into numbers and symbols. Okay. So this is what I got from statement 1.
Is it another definition, the next one?
Well, numbers, this, we see that on the picture, so we have to look at the picture.
I left the pass. I go to the pass.
We need to get it, but next time go a bit faster.
Okay.
So angle 1 is congruent to angle 4, angle 2 is congruent to angle 3.
Is it one of the things we learned yesterday?
It is not. It's something we learned in chapter 1, but we also talked about it again yesterday. What do you think?
Congruent?
Hold on. The vertical angles.
Oh.
And we know that vertical angles are congruent. So it's the vertical angles theorem, but if you just write the phrase vertical angles are congruent, that is also fine. So if it's just that it's just what it means, it's a definition. If you know that it's a fact, okay, so here's the thing. If you know that it's a fact, but you forget what that actual fact is called, you can just write vertical angles are congruent, say what it is. Okay, even if you don't remember if it's a vertical angles postulate or vertical angles theorem, you can just say vertical angles are congruent and just go with it from there. All right, now this next one we have done before. Okay. The next one we've done before. I've got 2 is congruent to 3, and that changes into the measure is equal. Here's this angle is congruent, and that changes into the measure is equal. So who thinks they know yet? Definition of congruent. Absolutely. Yep, definition of congruent. In this case, it's definition of congruent angles, but if you just wrote definition of congruent, you would be fine with that. Okay, so I took some things in here because I wanted to be able to use them because I'm thinking about my list of things that I know, thinking about the list of things that I know that will land me on parallel lines. And I had 5 of them. I went over 5 of them today. 5 things had, then the lines are parallel. Then the lines are parallel. Then the lines are parallel. So we're trying to work our way to something that gets us with the parallel lines. So I have this equation here, angle 1 plus angle 2 is 180. So how does that change into number 5? Angle 3 plus angle 4 is 180. Anybody see how that happened? Sort of, kind of. Yeah.
It's because if 1 and 2 are supplementary and equal 180, and 1 and 4 are equal, and 2 and 3 are equal, so then that makes 4 and 3 supplementary.
So 4 and 3 are supplementary because you took out the 1 and 2, right? And you replaced them with 3 and 4.
Yeah.
Because they're equal.
Yeah.
So what word does it mean when you replace something with something else?
I'm stuck there.
Stuck on that one? Yep. Substitution. Yep. Good. So substitution. You took one thing out, you took the 1 out and you replaced it with the 4. You took the 2 out and you replaced it with the 3. It doesn't matter that we changed order, that's fine. So you replaced something with something else that's the same value. And so every single one of these things is taking us down to the point where we can say that L is parallel to M. Okay. So angle 3 plus angle 4 is 180. So angle 3 and angle 4 are supplementary. Okay.
So definition.
Well, raise your hand and then I would love to call on you. Yes.
So it's a definition of supplementary.
Beautiful. It's also the definition of supplementary. Because them adding up to 180 just means that they're supplementary. And if it's just that it just means that, then it's a definition. It's even concurrently like, doing multitasking. I got you. All right, so so now that I know that these two are supplementary, I can conclude that L is parallel to N, and I'll tell you it's one of those converses that we talked about today.
Today?
A converse of consecutive interior.
Beautiful. The converse of the consecutive interior angles, because 3 and 4 are supplementary. They are consecutive interior angles from the picture. You need the picture for these
I have a
guys.
question.
Yeah.
So couldn't number 5 be vertical angle theorem again?
5 is not vertical
I mean-
angle theorem because the vertical angle theorem specifically says that the angles are congruent. Okay, so this isn't saying the angles are congruent. This is actually taking the angles out, replacing them with another thing. We've also taken the step of taking them out of their congruent form and putting them into their equals form so that it can be dropped in. Because technically you can't replace something that's congruent with something that's equals. Even though right now it kind of means the same thing, down the road there will be some things that congruent doesn't necessarily mean that a number would equal another number. I don't want to go in line with that right now, but so we have to have that step so that we can take it out and replace it. So not this step 5 can't be vertical angles. But, yeah. Okay. So we're gonna let that soak in a little bit. I have one. And I do plan to do the whole of tomorrow on this. I think I'd like to make up another group. Just to do from scratch.
Oh, is that's approved?
Yes.
That's a proof. I wanna make up another proof because I think if we can do a quick proof, then it would be good for you. Okay. I'm gonna do a quick proof.
You know what I mean? A quick-
You said that.
All right, so let's say, yeah, we can write this down. I'm gonna do a whole.
I'm doing that. That's the name of it.
Let's make it look somewhat similar to this.
Your face is just like hilarious every time I see it. Like I can't believe they took you off the case.
Actually, I'm gonna put 4 on. Yeah, let's put 4 on this side. So I'm gonna say.
I'm being bullied.
This one actually won't be necessarily fast, but let's just kind of see. That the measure of angle 1 plus the measure of angle 4 equals. There'll be a couple different ways to consider that. Let's just see what we can do with this. Okay, let's see what we can do with this. Given that we've got parallel lines. There's a few different ways we could get around to this, so we'll kind of see where you guys want to go with it. I know we don't have a whole lot of time, so we might not get through it all, but let's see what you think, what you're thinking. What's our thought? I'll take a picture of it and, oh, actually, okay, so people online, I know I've just put something on the board, so I'm gonna cut this right now. I'll put it up online for you tomorrow. So I'll say bye to you right now.
Bye.
Bye-bye.